Good morning, guys, of grade 11. Today, inshallah, we're gonna pass to section 2 of chapter 6. So, in chapter 6, section 1, we already know the types of the chemical bonding. We know what difference between ionic bond and the covalent bond, and how we could decide if we have two different atoms, they're gonna combine together, they are gonna form ionic bond or a covalent bond. And we said it depends on the difference of electronegativity. So today, inshallah, we're going to talk in details about the covalent bond. So section 2, covalent bonding and the molecular compounds. So actually here, okay, we're going to find, okay, that's the, we start first, what is covalent bond, or just to remember this, okay? Okay, guys, so here we said that today we're going to talk in details about the covalent bond and know how covalent bond is formed and what are the characteristics of covalent bond and so on. So first of all, we should know that there are a lot of atoms in nature or different elements in nature. They are bonded together by covalent bond. So once different atoms, okay, or even similar atoms, that means two or more atoms are joined together by covalent bond, we call it a molecule. So the word molecule just called, or it's a term which describe natural group of atoms that are bonded together by covalent bond, which means that, for example, sodium chloride, NaCl, is it considered as a molecule? Actually, no, because the difference of electronegativity between sodium and chlorine is more 1.7. So it means it's ionic bond. So once they are atoms are held by ionic bond, they are not considered as a molecule. So the word molecule just describe the atoms which are held together by covalent bond. So here, like this, we said that chemical compounds, which is just made of molecules, we call them, or the smallest unit of them, molecules, we call them molecular compounds. For example, like water. Water is made of H2O. Two hydrogen atoms are bonded to one oxygen atom by two single covalent bonds or by two covalent bonds. So in this case, the smallest unit of water, which keep the properties of water, is one molecule of water, H2O. I can't break it down anymore because if I break it more than this, it will be just separate into hydrogen and oxygen, and they will turn to other substances. So to keep the properties of the compound, which is the water, so it must be at least two hydrogen atoms bonded with a covalent bond with one oxygen atom. So we call this molecular compounds. So the compounds, which their simplest unit are molecules, we call them molecular compounds. So regarding to this, we have many, all the covalent compounds, they are molecular compounds. Like, for example, water, as we said. For another example, we can find glucose, C6H12O6. So that means all these number of the carbons, hydrogen, oxygen, they are attached to each other by covalent bonds. So like this, okay, it's a molecular compound. NH3, okay, that means like ammonia and H3. So the nitrogen is held by three covalent bonds with hydrogen. So like that, guys, okay, all these are molecular compounds.
Molecule.
So
A molecule is a neutral group of atoms held together by covalent bonds. Water.
So here like this, as we can see here, guys, water molecule, as we can observe, it's just made of one oxygen and two hydrogen atoms. They are bonded together. Even here we have oxygen molecule. Oxygen in nature is found in form of two. So we have some diatomic elements like oxygen, or most gases, oxygen, hydrogen, uh, nitrogen. All these already in nature, they found in form of diatomic molecule. That means a molecule made of two atoms of the same element. So also this considered as a molecular compound, or that, sorry, a molecular element. Here it's an element made of two atoms of the same kind. As we said here, we can find that saccharose, okay, molecule is C12H2O11, which represent many atoms. They are attached together by covalent bond. So all these represent different molecules. Whatever this molecule is, molecule of compound or molecule of element. So like this, when we say molecular compound, it means a compound that is already there, atoms bonded together by covalent bond. Molecular element or molecule of element, that means an element that's made of two atoms of that element. They are bonded together by covalent bond. So here we said that then, guys, this composition, or the composition of the molecule, that means the number of atoms and how much they are, or types of atom, and how much they are, that's represented by something we call chemical formula. So chemical formula indicates the relative numbers of atoms of each kind in chemical compound by using atomic symbols and numerical subscript. For example, when we say NaCl, so NaCl is a chemical formula that represents that one sodium atom is combined with one chlorine atom, so they form the NaCl. So here also we said that HPR, so that's one hydrogen atom is bonded to one bromine atom. So like this, they are represent the number and the type of atom. So although HPR and the NaCl, they are ionic, but chemical formula represent whatever ionic or covalent compounds. Okay. So in another example, for example, H2O, it represents that there are two hydrogen atoms bonded to one oxygen atom. So that's a chemical formula represent the type of the atoms or the kind or what are the elements involved in this compound and also how much atom of each element in that compound. If we just gonna describe the covalent compounds only, so we have something with molecular formula. So the molecular formula show the type and the number of atoms which are combined in a single molecule. And as we said, molecule just represent the covalent compounds only. So here we describe the covalent molecules only. So here molecules or molecular formula that represent the amount and the type of atoms in each molecule. Okay. For example, here, guys, as we said before, here that's one atom of sodium. Just that's one atom of sodium. So that's monatomic in nature. Sodium could found as one atom. But here, for example, fluorine, okay, it's found as diatomic. So it represents why here that is a compound. Okay, why it's compound? Because it, sorry, why it's a molecule? Because it's just two atoms. So it's element, diatomic element. What I mean by the diatomic element is that mean element made of one kind of atoms, but in nature it can't find a single atom. It must find in two atoms bonded together by covalent bond. Here, for example, water H2O, it's here a molecular compound, which means we have one oxygen atom bonded to two hydrogen atoms by covalent bonds. Okay. So like this, okay, whatever the chemical formula, we could figure out, for example, in glucose, C6H12O6. Okay, let's look here, guys, together. So when we said in glucose, okay, C6H12O6. So that is the molecular formula of the molecule of glucose. So we asked what we could predict out of this one. We could predict out that we have three elements are involved in that molecule. What are the three elements? Carbon, hydrogen, and oxygen. And also we could know the amount of each element. Okay, so in one molecule we have 6 carbons are bonded to 12 hydrogen and 6 oxygens. Okay, so like this, that's what we could predict from a chemical formula. Another example for example, let's say H2SO4. Okay, so that's a sulfuric acid. Okay, so here we could find in this chemical formula we have 2 hydrogen and we have 1 sulfur atom. Okay, and 4 oxygen. Okay, so like this, whatever the chemical formula, it could give you an idea about the types of elements which are involved in that compound and how much are these atoms. So here like this, I think it's clear now what meant by chemical formula. So we're gonna pass to the other point here, formation of covalent bond, or how the covalent bond or why covalent bond is formed. So we said that, as we said in the first section, in normal situation or the in nature, single atom always they have higher potential energy, which means it's not stable. So they try to stay stable or they try to decrease their potential energy. So they try to act. So for example, here we're gonna observe that here, if we have two single atoms, this each one, as we can see, when they are isolated or they are single, they are not bonded, they have higher potential energy. Okay, so once they become closer to each other, okay, the potential energy decreases until they reach a certain distance. Once they reach this distance, their potential energy decreased. In that case, we find they already formed a bond. Okay, so here like this, we find the potential difference. Okay, decrease, but actually that means they are gonna stop at this point. No, actually they are gonna repel or they are gonna get further a little. So that means during formation of covalent bond, the atom become closer to each other, okay, until they form the bond and they start to repel, agree, until they stretch or take the maximum length of this bond. How that happen? Let's see. To explain the formation of covalent bond, we're going to take the simplest example ever, which is the covalent bond between two hydrogen atoms, as hydrogen just has one electron and one proton, so it will be easier to explain for you. So here, once two hydrogen atoms, as illustrated here in the figure, represent how the form is gonna, how the bond is gonna form. So simply, we are gonna find there are different forces gonna be exist between these two atoms. First, we have a kind of repulsion force that happen between the two nuclei. Okay, the two nuclei are positive, so they repel each other. the electron cloud or the energy levels, they are negative charge because of presence of electrons, so also they repel each other. But in the same time, we're gonna find that the positive nucleus of this atom could attract the electrons of the other atom, and the nucleus here, okay, of this atom could attract the electrons of that one. So we have a kind of repulsion and attraction force, but overall, the attraction of nucleus to the electrons is more. Why? Because we know that nucleus has, or the protons have larger mass compared to the mass of the electrons, so of course their attraction force will be more and more. So we're gonna find finally the attraction force will overcome the repulsion force, and that will create a kind of bonding. Okay, so here we said that these two forces cancel out from the covalent bond at length, so that means the two bonds, they are gonna attract to each other, but they will not be completely merged. They will stand, or they will have a certain difference, or a certain, sorry, distance between the two nuclei, which represent the length of that, I mean at that length, or at that separation distance between the nuclei of the two atoms, the two atoms become more stable. Okay, here, or they have the lowest potential energy ever. Okay, so here like this, as we could figure, after bonding, okay, we are gonna find that they will form this shape. We have now our element molecule made of two hydrogen atoms, and as we can see, this distance represent the most stable, okay, case for these two atoms. They can't be any more closer or any more farther. If they are any more closer, the repulsion force between the nucleus will pull them away, and if they are farther, okay, they will be attracted. So that means that's the only situation in which they are going to be stable. Okay, guys, so line this, okay, we know what meant by, or how that covalent bond is formed, or what determine the distance here, or what is gonna represent the distance between the nuclei of the two atoms in a covalent bond. So here like this, okay, let's go through the characteristics of a covalent bond. So we see the distance between the two bonded atoms, okay, once they reach the minimum potential energy, that means once already the bond is formed and now they are stable, they can go further or closer to each other. We call this the bond length. Okay, so here the bond length represents the distance between the nuclei of the two atoms, or the distance between the two atoms when they are at the lower potential energy or the minimum potential energy. So in forming covalent bond, the hydrogen atoms release energy. The same amount of energy must be added to separate them. That means during formation of bond, or during making bond, there are energy is released. So to break this bond, we must apply, or we must provide the molecule with the same amount of energy which they released. For example, if the two hydrogen atoms, once they bonded, they release about 5 to 50 joules. So to break a molecule of hydrogen, we must provide this molecule with energy equal 50 joules. So we call this a bond energy. So what is bond energy? It is the energy required to break a chemical bond and form a natural isolated atom. That means to return this molecule again one more time into separated ions, or sorry, separated atoms or isolated atoms, we must provide them with a certain amount of energy, which known as bond of energy, which equals the amount of energy that already released during the formation of the molecule. Okay, so here we could figure there is a relation between the bond length and the energy. Okay, there is a kind of relation between them. Of course, there is a kind of relation between them. So what is the relation between them here? Okay, so we could find, as we can here, the potential energy and then the distance between them. So a bond forms when the atoms are a certain distance from each other. At this distance, the atoms are in the low energy state. If they are closer together or further apart, they will be on unstable situation. So that is the most stable situation that represented by the length. So we could figure out, as the distance increases, or the more bond length we have between the two atoms, we're gonna find here the less energy that we got. Okay, so or the less energy we needed, or bond energy we need to break them. So the more closer the atoms together, the more attraction between them. That means they are held together more strongly, so they require more energy to be broken down. Okay, so that's here the idea that represent that. So we're gonna find that the idea of the bond length and the bond energy. And also here there is something important, okay, to know, that it varies or depends on the kind of bond that will be formed. So you're gonna have in your textbook, okay, page 182, you're gonna find a table that represent the different compounds or different molecules that represent the average the average bond length and the average bond energy. So you could figure out there is a relation between the bond K length and the bond energy, but it depends. So it's not a must that as it increases, okay, or the way as the bond length increases, the energy decreases. Okay, it's not a must, but okay, we could figure that it depends on the kind of the molecule here we have. So regarding to this, we need to remember that the bond length, okay, is measured by a measuring unit we call PM or picometer, okay. So picometer is equal 1 by 10 power of negative 12, okay, of the centimeter, okay. While here we find that bond energy is measured by kilojoule per mole, okay. That means how many kilojoules are produced for 1 mole, okay, of this substance. That's the part of our lesson today. Next time, inshallah, we're again continue this our section. Please study well from your textbook, and if you have any question, you can ask anytime. Thank you, guys. Goodbye.